इन नॉर्थ ईस्ट, उसका कैचमेंट एरिया अलग है, उसका कैचमेंट कैरेक्टरिस्टिक्स अलग है, ठीक है। गुजरात साइड, महाराष्ट्र साइड, द कैचमेंट कैरेक्टरिस्टिक्स आर डिफरेंट, ओके। इन दिस साइड, वेस्ट बंगाल, ओडिशा, ओके, आंध्र प्रदेश, दैट कैचमेंट एरिया इज डिफरेंट टाइप। सो एम्पेरिकली अलग अलग रीजन में अलग अलग फॉर्मूला डिटरमाइन होता है। So some important empirical formulas. Only two we will study. There are many formulas. आप देखना हाइड्रोलॉजी के बुक में नवाब जंग बहादुर फॉर्मूला, ठीक है, एक्स वाई जेड बहुत सारा फॉर्मूला, बट डिकेन्स फॉर्मूला एंड रीव्स फॉर्मूला आर पॉपुलरली यूज्ड, ओके। So Dickens formula states that QP, which is the quantity of runoff or storm water generated in meter cube per second, is equals to C into m raised to the power 3/4, where m is the catchment area in kilometer square. आप इसको a से भी रिप्रेजेंट कर सकते हैं, C into a raised to the power 3/4. That will also be okay. A or m is the catchment area in kilometer square, and C is the constant depending upon factors which affect runoff. C is generally used 11.5. So if in the question you are given area of catchment is suppose 150 hectares or so, or in kilometer square it is given, okay, a larger catchment area. The value of C is not given. You will have to assume, if you use Dickens formula, you will use C as 11.5. ये याद रखो, ठीक है। रीव्स फॉर्मूला, दिस फॉर्मूला इज जनरली एप्लीकेबल फॉर साउथ इंडियन कैचमेंट्स, यानी साउथ इंडियन कैचमेंट एरियाज, साउदर्न पेनिनसुलर रीजन्स के लिए दिस फॉर्मूला होल्ड्स गुड। सो रीव्स फॉर्मूला इज सिमिलर टू डिकेन्स फॉर्मूला। हियर C into m raised to the power 3/4, here C into m raised to the power 2/3, okay, where m or a is the catchment area in kilometer square. So these are the catchment areas and these are the values of C. Popularly you will use Dickens formula. You are free to use if the area is larger catchment. Okay, you can also use Reeves formula, but Reeves formula generally holds good for South Indian peninsular region. This is one more formula, Dredge or Burgess formula. So this formula is based upon Indian records that states that QP is equal to 19.6 m by L raised to the power 2/3. You try and remember at least Dickens formula and Reeves formula. वो दो formula आप याद रखिए empirical. Now one question. Determine the design discharge for a combined system serving a population of 50,000. What is the population that is being supplied with water? 50,000. Population कितना है? 50,000. Rate of water supply is 135 LPCD. LPCD means liter per capita per day. That means liter per person per day. एक व्यक्ति के लिए, one person के लिए 135 liter is the water requirement. Correct? The population that is being served is 50,000. Now you are asked, the catchment area is 100 hectares. Okay, the catchment area is 100 hectares. And the average coefficient of runoff is 0.6. The coefficient of runoff is given as 0.6. The time of concentration for the design rainfall is 30 minutes. And the relationship between intensity of rainfall and duration is IC equals to. This is the formula for finding out the intensity of rainfall. Okay. Now, what they are asking? Determine the design discharge for combined sewer system. I told you there can be 3 sewer systems, right? Separate sewer, combined sewer, and partially separate or partially combined sewer. What is the population that is being served? 50,000. Per capita water demand is given. You have to find out the total sewage and the total drainage that is going to be generated, and that has to be facilitated. So how we will determine quantity of sewage? How we will determine the population being served is 50,000, correct? Per capita water demand is 135 LPCD. So you multiply 50,000 with the population of that region. 1 person requirement of water is 135. So 50,000 persons will require 50,000 into 135 liters per day. Okay. Whatever the value you will get, that will be the quantity of water supplied. Okay, quantity of water supplied. That will be in liters, right? 135 liters. So this will be the whatever you are value getting, that will be in liters. You will have to convert into meter cube. How to convert liter to meter cube? You remember 1 meter cube is equal to 1000 liters. That means 1 liter is equal to 10 raised to the power minus 3 meter cube. Correct? So whatever value you are getting, multiply that with 10 to the power minus 3, you will be getting the total quantity of sewage, total amount of water that is supplied. Now I have told you a thumb rule. 80% of the water supplied to any area turns into sewage. Correct?
Yes, sir.
That means आप उसका 80% निकालोगे. 80% of that water you will find, that will be the quantity of sewage generated. ठीक है ना? Whatever value you have got in meter cube per second, multiply that with 0.8. Why? Because 80% of the water supplied in an area turns into sewage. So we have estimated the quantity of sewage. Now we want to estimate the quantity of drainage, storm water that is going to be generated. What are the things given? The catchment area is 100 hectares. That means rational formula was good enough for up to 50 hectares. Okay. So we are very free to use Dickens formula or Reeves formula. अब कोई स्टूडेंट अगर इसको रैशनल मेथड से सॉल्व करते हैं, ठीक है ना, सो दैट एग्जामिनर कैन करेक्ट इट. ओके, वो स्ट्राइक डाउन नहीं कर देगा बिकॉज द एरिया इज नॉट दैट मच लार्ज. सपोज 500 हेक्टेयर्स, 1000 हेक्टेयर्स, it's not that enormous area. Okay, 100 hectares catchment. In terms of catchment, 100 hectares is not that large. Any student, if uses rational method, he or she is free to do that. So anyhow, the catchment area is given. We know A. How much? 100 hectares. Okay. The coefficient of runoff has been given. What is the coefficient of runoff? 0.6 here. Correct. And the intensity of rainfall is not given. IC is given. No. There is a formula stated. IC is equal to 100 divided by T plus 20. Okay? And what is this T? T is the design rainfall for 30 minutes. So simply you put 100 divided by 30 plus 20. Okay? That will be the value in 2. What will be the unit? I think it will be centimeters per hour. Okay. Regarding millimeter or centimeter, nothing has been told, na? But this formula, I think this is just a empirical formula for rainfall rainfall intensity. It will be in centimeter per hour. So we are getting 2 centimeters per hour rainfall intensity. Then we can use either Reeves formula or Dickens formula. Okay, we can also use rational method. तीनों से आंसर आप डिटरमाइन करके देख सकते हैं. Okay, if you solve a rational method, that also will not be wrong. But since the area is more than 50 hectares, we can use Dickens formula. C into A raised to the power 3 by 4. Okay. So you'll try and find out this answer. Next class we will discuss. Okay. But I am repeating that if you solve it by rational method, that will not be wrong. Okay.